When you guys did your discussion, a lot of you mentioned Pythagorean theorem. Some people mentioned special right triangles. All those things are important for right now. So I'm glad that I saw those coming up when I said, what do you remember from geometry? You guys remember the things I needed you to remember. Okay. Well, most of you, some of you, I don't know, but most of you did. So let's talk about part C. So in part C, we're going to dive into the unit circle and building up the unit circle. What does it say you must do for the unit circle? Memorize it, okay? We will have our first 5-minute memory quiz next Tuesday. Like Tuesday. We're going to have our first 5-minute memory quiz. All right? We will have a unit circle quiz every week. Because by the time all said and done, this thing right here, you're going to be doing it in your sleep, okay? Don't worry. Trust the process, okay? It didn't fail me, and it's not going to fail you now. If you want to be mad at anyone, you could be mad at my pre-cal teacher. Her name was also Mrs. Jones. Really, it was. All right, here we go. So, geometry connection. Dun, 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 dun. 30, 60, 90 triangles and 45, 45 triangles. These are what you called your special right triangles in geometry. Agreed? What made them special is that these triangles had ratios that allowed you to know if you know one side, then you can find all the other two sides versus having to have to know two sides of the triangle. Do y'all remember that? Okay, so that is what made them special. In that same regard, that is how we fill the blanks around the unit circle. Knowing those ratios and what those values are, that's how we're going to fill around the unit circle. Okay, so let's talk about, before we label here, we're going to talk about name the lengths of the sides of the hypotenuse is 1. So is our end game here. And we need to keep this in mind because this is what helps us get around the unit circle. Okay. Starting off, we have for 30, 60, 90, its corresponding sides ratios are x, x squared to 3, and 2x. Okay. Meaning that across from 30, that's what we call our x side. So here's 30. Across from 30, that's not an x. But that was a really good 3. I don't know why I wrote it, but it was a really good one. And I want y'all to acknowledge it. Yeah. A crystal or just crystal? Oh. Okay, that's our x. Across from 60, that is x square root of 3. And then across from our 90 is our hypotenuse, and that's going to be 2x. So in terms of if my x side, if my hypotenuse is 1, right? So if my hypotenuse is 1, what is happening? What is the ratio that's taking place? So if my hypotenuse is 1, that means across from 90, it would be 1 unit. And then from there, what happens? If 2x equals 1, what does that mean x has to be? 1/2. Does that make sense? So if your hypotenuse equals 1, as it says, let your hypotenuse be 1, that means that x has to be what? 1/2. And 1/2 is x is across from 30. So across from 30, you have 1/2. And if x equals 1/2, what does that mean across from 60 equals? 1/2 square root of 3. So I'm just going to write square root of 3 over 1/2. These are very important numbers. They're going to be used for the rest of your life in this class. All right. But do we see where they came from? Okay, let's go over it again. I heard a no, because if you don't know where they came from, it's going to be harder for you to memorize. So it says this is from geometry. Do you remember this? X squared root of 3 and 2x. Okay. These are the ratios of the sides for a 30, 60, 90, meaning that if I know the value of any one side, I can use that to solve for x and find the rest of them. So it said right here, name the lengths of the sides if your hypotenuse is 1. Our hypotenuse would be our 2x. So if 2x equals 1, what does that mean x would have to be? Well, if 2x equals 1, x would have to be 1/2, right? Agree? I'm trying to get the people who said they didn't understand. Yeah? Do I need to write it out? Just tell me. Because I really want to make sure you get it. Because if not, we're in trouble. If 2x equals 1, that means x has to be 1/2. Now we're good? We see here? All right. That is how we got that x equals 1/2. X is across from 30. So that is the value of 30. So the value of the side from 30 is 1/2. Now that I know what x is, can I say what is across from 60? Across from 60 is 1/2 times the square root of 3. Well, I can combine them and make it square root of 3 over 2. Got it? And that's where these numbers came from. All right, we're going to do the same thing now with our 45, 45, 90. So in geometry, you should have learned that the ratio between the sides of a 45, 45, 90 are x, x, and x square root of 2. In this case, it says we're going to let our hypotenuse equal 1. So I'm letting x square root of 2 equal 1. So therefore, what is x? X would equal 1 over the square root of 2. Is that mathematically correct to write? There we go. You can't have a radical in the denominator. So I have to rationalize. In order to rationalize, I'm just going to put a disguise on 1. And this disguise for 1 is going to be the square root of 2 over the square root of 2. Because anything divided by itself is still 1. So therefore, x actually equals the square root of 2 over 2. Yes? And these are the values of, okay, what's this? What is square root of 2 times square root of 2? Square root of 4. And what's the square root of 4? 2. Oh, A square times itself eliminates the square. Good. Good. All right. So now we know what's across from the 45. So across from the 45s is going to be the square root of 2 over 2. And we already know across from 90 is 1. Yes? Agreed? All right. Keep those numbers in mind. They're your friends. Trust the process. It was an overlay. I forgot to delete last year's. It's terrible. But I pretty much wrote the same things. All right. So how does that work? Oh my gosh. They come together? That's crazy. All right. The coordinates. Okay. So when you are finding sine, cosine, and tangent, remember how we talked about sine equals your what variable? Y. Cosine equals your what variable? And your tangent is your y over x. All those things are our friends, guys. So when we have a unit circle, that means that the radius of that circle is a unit, which is 1. So everything is based off 1, which means that everything is based off of those numbers we just went over. That's so beautiful. I love it. And I love how it comes together. Okay. So thinking about your right triangle, which I need us to go back to. If I'm looking for the sine of 30, right? So the sine of 30 is going to be, sine is old hippie, right? Opposite over hypotenuse. Opposite would be across. Hypotenuse would be 1. So when we have those values, that's what we're going to be using. So I'm going to draw the right triangle and we're going to go from there. Cool? For me, on every unit circle that I drew, I always drew the right triangle at the top of it, just in case I forgot what things were. So I always drew my special right triangles. Because this is a 30, the special right triangle that I would have here is going to be a 30, 60, 90. 30, 60, 90. I know that the hypotenuse is 1. We said across from 30 is what? What did we say was across from 30? 1/2. And what did we say was across from 60? Square root of 3/2. This is my special. This guy right here is going to help you know everything you need to know as far as most of the stuff on the unit circle. Right? Why are you giving me the death stare? I don't know what I teach y'all in there. I don't think it's part of how in your curriculum. It's not laid out for me to teach you like that. Can't blame me. It was a joke, Andrew. Gosh. Of course you would take me literal. Yeah, I think at that point they're assuming you know you are able to make the connection. Because you know we have less time to learn it. Yeah. In here I'm supposed to make the connection. Yeah, so all right, so we're gonna find sine, cosine, and tangent of 30 degrees. Okay. Finding sine, cosine, and tangent of 30 degrees is gonna go back to your special rights triangle. Okay. That's our SOHCAHTOA, some old hippie, whatever you learned it is, that's what we're using essentially. It all comes together. Okay. So if I'm looking for the sine of 30, the sine of 30 degrees, this is 30 degrees. It is opposite over hypotenuse, correct? So the sine of 30 equals what? What's my opposite? 1/2. And then my hypotenuse is 1. Is there any reason to write that? No. So the sine of 30 is 1/2. So what that means is that at 30 degrees, that's your y value. Because sine represents what? The y. Okay? Cosine of 30 degrees. Okay? Cosine, what is cosine? Adjacent over hypotenuse. What is adjacent to 30? And my hypotenuse is 1. Is it necessary to write? No. So then this is my x-coordinate. So at 30 degrees, the point on the circle would be at square root of 3/2, comma 1/2. See? Yes? All right. Tangent is not going to be on your circle because it's not part of the circle, but to find the tangent, we know that's our opposite over our adjacent. What's our opposite? 1/2. What's our adjacent? Square root of 3/2. Isn't that the same thing as our y over x? 1/2 over square root of 3/2. Okay. How do you multiply? I'm sorry. How do you divide fractions? You multiply by the reciprocal. And what's our shortcut to remember that? Keep, change, flip. Okay. When you are dividing fractions, you are multiplying by the reciprocal. Do we remember that? Our shortcut to remember that is we KCF. We keep, change, and flip. So we keep the numerator. I'm going to do it over here so I have more space. I have 1/2. We change from division to multiplication, and we flip our denominator. So instead of square root of 3/2, it becomes 2 over the square root of 3. You have the same value in the numerator and the denominator, so they do what? Cancel. So you're left with 1 over the square root of 3. Red flag, red flag. What's my red flag? Can't have that darn radical. Oh my gosh, look at it being so extreme. You get it? No? Nobody got it? No? Okay. Totally. All right, so we're going to put on a disguise for our 1. 1 gets a disguise, and we're left with the square root of 3/3. So the tan at 30 is square root of 3/3. Not for the unit circle, but just that you know how to find it. Yes. Use what right here? Which part? That's a 3. A 3 and a 3. Got a little extra weird. Yes. Because when you multiply a radical times itself, the radical goes away. Right. That is what that is. We're gonna put it all together at once. But yes, it is. All right. You're gonna be using so this is a triangle that we would use for 30 and 60. Agree? Does that make sense? Yeah. So for 30 and 60, we'd use this exact same triangle, or surprise, surprise, they're opposites of each other. Why are they opposites of each other? Because the opposite of 60 is the adjacent of 30. The adjacent of 60 is the opposite of 30. So you already know what their sine and cosine are because they are opposites of each other, which we'll dive more into in a second. All right, 45, 45. 45 degree. I obviously am not using the 30, 60, 90, am I? No, I'm going to use the 45 degree triangle. So I have my 45 degree angle. I'm trying to make them equal as much as possible. Pretend that those sides are equal. You know, I'm going to mark them as equal because in geometry we learn if you mark it, then you got to believe it. So I marked it. There you go. Now you know. Okay, they're equal because they are marked congruent. All right. So we know that therefore these have to be 45. My sides are equal, and these have to be 45. And we know that across from 45, what did we say the value was if the radius is 1? If the hypotenuse is 1? Square root of 2 over 2, square root of 2 over 2. Oh my gosh, look. They're right there. So the sine of 45. Sine is your opposite over your hypotenuse. Well, my opposite is square root of 2 over 2. My hypotenuse is 1. Is it necessary for me to write? No. So therefore, the y value is square root of 2 over 2. Cosine of 45. Oh my gosh, it's the same thing. It's crazy. Now, tan of 45 is my favorite. Anyone want to know why tan of 45 is my favorite? Tangent. Tan is y over x. If my y and x are the same, what does that mean that has to be? It's 1. I know. That's why it's my favorite. Tan of 45 is my favorite. Because it's just 1. I don't do anything. I don't think about it. It's the same number in the numerator. It's the same number in the denominator. It is 1. But in the notes, it doesn't tell me to teach you anything about triangles. All right, 60. So now we're at the 60-degree angle. 60-degree angle. Again, you're still using your 30, 60, 90. I'm going to redraw it because I don't have it on the same page, but you have it still drawn, don't you? Do you? I mean, if you don't want to flip back and forth. But I'm just going to redraw mine so I don't have to flip back and forth. That got a little, that's bad. I couldn't even lie. I was going to tell y'all to pretend, but that would have been just terrible. Okay. Y'all didn't have to have that reaction. I saw it before you said anything. Dang. I was going to catch it. Yes. I was really about to tell y'all about it. All right. And 1. So we're starting off with the sine of 60. Sine is your opposite over your hypotenuse. What is my opposite of 60? And divided by 1 is just itself. So therefore, my y value is square root of 3 over 2. Your cosine of 60 is your adjacent over hypotenuse. My adjacent is 1/2. Therefore, my x is 1/2. Oh, tan of 30 and 60, you have to do a little bit of work, which is just so annoying. So tan of 60 is not as fun as tan of 45. Tan of 60, your y divided by your x, or your opposite over your adjacent. You're dividing. which means that you're multiplying by the reciprocal. Agree? So I'm multiplying by the reciprocal. So I have square root of 3 over 2, which is my y, times the reciprocal of 1/2. What is the reciprocal of 1/2? Over 1. I have a 2 in the numerator and a 2 in the denominator. What do they do? Cancel out. So I'm just left with the square root of 3 over 1. That's cool. What's anything divided by 1? It's